This problem involves rolling a 20-sided die. If a 20-sided die is rolled, what's the probability of getting a number bigger than 11 or a multiple of 4? So let's first talk about what we can get when we roll a 20-sided die. So if I roll a 20-sided die, I can get a number from 1, 2, 3, all the way up to 20. So the possible things I can get when I roll a 20-sided die is 1, 2, 3, 4, 5, numbers 1 through 20. Now, I'm talking about numbers bigger than 11, numbers that are multiples of 4. So the bigger than 11s, let me circle those. So bigger than 11 means you don't include 11. So bigger than 11 will be 12 all the way up to 20. Circled numbers are numbers bigger than 11. The other types of numbers I'm interested in are multiples of 4. That means we're going to count by 4s. These I'll box. So 4 plus a 4 will be 8, plus another 4 will be 12, plus another 4 will be 16, and then plus another 4 will be 20. Okay, circles are numbers bigger than 11. Boxes are my multiples of 4. So for this question, keyword there is the word or. Okay, the bottom is going to be all the different numbers I can get, which are 1 through 20. How many are there? There's 20 different numbers. Now, or means I want to take all the numbers bigger than 11 and then combine them with all the numbers that are multiples of 4. So take all my numbers that are circled and combine them with all the numbers that are boxed and then count them. So basically, I'm counting all the numbers that have a red mark on them. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Part B, if a 20-sided die is rolled, what's the probability of getting a number bigger than 11 and a multiple of 4? Keyword there is the word and. Okay, bottom is going to be all the different numbers I can get. So how many are there? There's 20 of them. For top, the word and means at the same time. So I want the numbers that are bigger than 11 and at the same time multiples of 4. So the numbers that are circled and at the same time boxed. So which numbers are circled and boxed at the same time? 12, 16, 20. So there's 3 of them. Part C, if a 20-sided die is rolled, what's the probability of getting a number bigger than 11 given that the number is a multiple of 4? Keyword is the word given. So I'm looking for probability of bigger than 11 given multiple of 4. So anytime I have the word given, right, I need to focus on a subset of the numbers. So for this one, we're focusing on the given part, which is the second part, the multiples of 4. For the top and the bottom. Okay, so focusing just on the multiples of 4, which are the boxes, how many are there total? So just the boxes, that's 1, 2, 3, 4, 5. And then still focusing just on the boxes, how many are bigger than 11? So just the boxes, how many are bigger than 11? That would be 1, 2, and 3. Part D, if a 20-sided die is rolled, what's the probability of getting a multiple of 4 given, so once again, the word given, that the number is bigger than 11? So in symbols, I'm looking for multiples of 4 given bigger than 11. Okay, anytime I see the word given, that's telling me to focus on certain numbers. Here I'm focusing on the second part, which is the bigger than 11. For the top and the bottom. So focusing just on the numbers bigger than 11, how many are there total? Bigger than 11 are my circles. So how many are there total? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So focusing just on the circles, there are 9 total. And then for the top, still focusing just on these circle numbers, how many are multiples of 4? So just these circle numbers, how many are boxed? 3. Part E, if two 20-sided dice are rolled, what's the probability that both are multiples of 4? Okay, so we're talking about 2 dice now. I'll need 2 fractions. And both of them I want to be multiples of 4. So multiple of 4 and multiple of 4. Okay, bottom of the first fraction, the total of all the different numbers I can get. So how many different numbers can I get? That's going to be 20. Now, when we're talking about dice, we don't reduce because whatever happens on the first dice, it doesn't affect what happens on the second dice. So you don't reduce for dice. So the second fraction will also be 20. Top, multiples of 4. How many multiples of 4 do I have? Multiples of 4 are my boxes. So that's 1, 2, 3, 4, 5. Now for dice again, we don't reduce. So for the second fraction, another multiple of 4, that will be 5 again. For F, if two 20-sided dice are rolled, what's the probability that the first row is bigger than 11 and the second row is a multiple of 4? Once again, 2 dice. First one, I want to be bigger than 11. And the second one, multiple of 4. Okay, bottom, how many different numbers can I get? That's going to be 20. And once again, we don't have to reduce because it's dice. So the second one will also be 20. First fraction, bigger than 11. How many are bigger than 11? Bigger than 11 are my circles. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiples of 4. These are my boxes. That's 1, 2, 3, 4, 5. And once again, I don't have to think about reducing because we're talking about 2 dice here. Part G. If two 20-sided dice are rolled, what's the probability that at least one number is bigger than 11? So keyword, at least 1. So anytime I'm talking about at least 1, I know my final answer is going to be 1 minus some fractions. So I'm looking for probability at least 1 bigger than 11. Okay, and the way we calculate at least 1 is going to be 1 minus none. So 1 minus none bigger than 11. So our answer is going to be 1 minus, how many fractions do I need? We're talking about 2 dice, so 2 fractions. 2 dice, both of them not bigger than 11. Okay, so not bigger than 11 and not bigger than 11. Okay, that's what it means for 2 dice, none of them bigger than 11. So 2 dice, not bigger than 11, not bigger than 11. The bottom of the fractions, how many different numbers can I get? That's going to be 20 for both because we don't have to reduce for dice. For the top, I want the numbers that are not bigger than 11. So bigger than 11 are the circles, so not bigger than 11. So what are not circled? Not circled would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so those are the numbers that are not bigger than, or yeah, those are the numbers that are not circled. So there are 11 numbers that are not circled. Second fraction, I also want to be not bigger than 11. So, and we don't have to reduce because we're talking about dice. So the second fraction will also be 11. So final answer will be 1 minus 11 over 20 times 11 over 20. Part H, if two 20-sided dice are rolled, what's the probability that at least one number is a multiple of 4? So keyword, at least one. So at least one, I know my answer will be 1 minus some fractions. So we're looking for at least one multiple of 4. Okay, and the way we find at least one is 1 minus none. So 1 minus none, multiple of 4. 1 minus, how many fractions do I need? Talking about two dice, so 2 fractions. 2 dice, none of them multiple of 3 or multiple of 4 means I want not multiple of 4, not multiple of 4. Bottom of the fractions, how many different numbers can I get? That's going to be 20. And then I don't reduce because we're talking about dice, so 20 for the second one also. How many numbers are not multiples of 4? Multiples of 4 are my boxes, so how many numbers are not boxed? So not boxed would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 numbers that are not boxed. Okay, second fraction, also not multiple of 4. We're talking about dice, so we don't reduce. That will be 15 again. Final answer, 1 minus 15 over 20 times 15 over 20. We'll be working with a deck of cards in this question. Part A, if a card selected from a standard deck of cards, what's the probability of getting a king or a heart? Keyword I see here is the word or. Okay, we're talking about selecting a card, so we'll just need one fraction. Bottom's going to be all the different cards how many different cards can we choose from? So the total number of cards in a deck of cards is 52. The word or means I want to take all my kings, combine them with all the hearts. So all the kings together with all the hearts. All the kings is this last row together with all of the hearts. Okay, remembering not to count the king of hearts twice. So let's do all the hearts. That's 1 through 10, and then JQ king, that's 13. Then add on the other kings, so that's 13, 14, 15, 16. So 16. Part B, if a card selected from a standard deck of cards, what's the probability of getting a face card and a heart? Keyword is the word and. Okay, we're talking about a card, that's one fraction. Bottom's going to be how many different cards can we choose from? There's 52 total. And the word and means at the same time. So I want the face cards that are at the same time hearts. So in other words, I want the heart face cards. So heart face cards are just Jack of Hearts, Queen of Hearts, King of Hearts. 3. Part C. If a card selected from a standard deck of cards, what's the probability of getting a face card given that the card is a heart? Keyword, given. Okay, I'm looking for probability of face given that it's a heart. So anytime you have the word given, it's telling you to focus on just some specific cards. So this is telling me to focus on, okay, and the part you're focusing on is the second part, which is the heart. So anything that comes after the word given. So focus on hearts for the top and the bottom. So focusing just on the hearts, so just on this third row, how many are there total? So just the third row, there are 13 total. Okay, that's the bottom. And then for the top, still focusing on just the hearts, how many are face? So just the hearts, how many are face cards? That will be just the Jack, Queen, King of hearts. So 3. Part D, if a card selected from a standard deck of cards, what's the probability of getting a red card given that the card is a face card? Keyword is given. So in symbols, we're looking for probability of red given that the card is a face. Okay, anytime I see the word given, that's telling me to focus on certain cards. So we're going to focus just on the second part. So anything that comes after the word given. So given that the card is a face card. So we're focusing on just the face cards for the top and the bottom. So focusing just on the face cards, how many are there total? Face cards are going to be the last 3 columns here. So focusing just on the last 3 columns, how many are there total? So that's Jack, Queen, King, and then four rows of them. So that's 3 times 4, 12. So there are 12 face cards total. And then still focusing for the top, just on the face cards, so just the last 3 columns here, how many are red? So just the last 3 columns, how many are red? That would just be the Jack, Queen, King hearts and Jack, Queen, King diamonds. 6. Part E. If 3 cards are selected from a standard deck of cards, what's the probability the first card is black, the second card is a red king, and the third card is a red face card? So we're talking about 3 cards, I'll need 3 fractions. And it says here, I want the first card to be black. Second card is a red king, so red K. Third card, red face card. Okay, for the bottom, the first fraction will be how many different cards can I choose from total. There's 52 cards total. And so for cards, when I pick a card, I'm not putting it back. So because I'm not putting it back, for the second fraction, the total is going to go down. It's going to be reduced. So it's going to be reduced to 51 and then 50. Okay, first card, black. How many black cards are there? Black cards would be the first 2 rows. So first 2 rows would be 13 on each row. So 13 times 2, 26. Second card is a red king. How many red kings do I have? Red kings would be King of Hearts and King of Diamonds, so 2. And then the question is, do I have to reduce here? So the question is, have I used any red kings yet? No. First card is black, so I have not used any red kings yet. So I should have the full 2. Last card, red face card. Okay, so red face cards would be Jack, Queen, King hearts, Jack, Queen, King diamonds. So 6. Question is, do I need to reduce? So have I used any red face cards yet? First card is black, so that would not be a red face card. Second card is the red king. A king is a face card, so I did use a red face card for the second card. So I do have to reduce by 1. So red face normally would be 6. I have to reduce by 1. It's going to be a 5. Part F, if 3 cards are selected from a standard deck of cards, what's the probability that the first card is a red king, second card is a red face card, and third card is a red card? So 3 cards. First card is a red king, so that's red K. Second card, red face card. So red face. Third card, just red. Let's talk about the bottom first. Bottom of the first card, how many different cards total? 52. So when we're talking about cards, I'm picking a card, not putting it back. So because I don't put it back, for the second card, right, the total is going to be reduced by 1 to 51. And then for the same reason, we're going to be down to 50. Now, first card, red king. How many red kings are there? King of hearts, king of diamonds, 2. Second card, red face card. How many red face cards do I have? Red face cards would be jack, queen, king, hearts, jack, queen, king, diamonds. That's 6. Question is, have I used any red face cards yet? And the answer is yes. I did use a red king for the first card. So that's a red face card, which means I have to reduce by 1. So red face would be not 6, but 5. And then last card, red cards. How many red cards are there? Red cards would be the bottom 2 rows. Okay, so each row has 13 cards. So bottom 2 rows would be 26. Question is, have I used any red cards yet? Yes, right? First card, red king, that's red. Second card, red face, that's red. So I've used 2 red cards already, which means I would have to reduce by 2. Okay, so red cards total will be 26. Because I used 2 red cards already, reducing by 2 would bring me to 24. Part G. If 3 cards are selected from a standard deck of cards, what's the probability that at least one is a face card? So keyword there is at least one. So anytime I have an at least one probability, I know the final answer is going to be 1 minus some fractions. So I'm looking for probability of at least one face. Okay, and the way we do at least one probabilities, we're going to do 1 minus none. So 1 minus the probability of none face. So our answer is going to be 1 minus, how many fractions do I need? Talking about 3 cards, so 3 fractions. 3 cards, none of them face. That means that I want not face, not face, not face. So all of them not face. Okay, that's what it means for none of them to be face. So I want not face, not face, and not face. The bottom of the fractions. First one, how many different cards can I choose from? That's 52. And then once again, I do have to reduce because I'm not putting these cards back. The 51, 50. Okay, I want to count the not face cards. Not face cards would be 1 through 10, 1 through 10, 1 through 10, 1 through 10. So 1 through 10 on all 4 rows. That's going to be 1 through 10 times 4. That's 40. Next card, I also want to be a not face. And because we're not putting the cards back, right? I do have to reduce. So the next one will be down to 39. And then another not face, we will be down to 38. So final answer is going to be 1 minus 40 over 52 times 39 over 51 times 38 over 50. Part H, if 3 cards are selected from a standard deck of cards, what's the probability that at least one card is a club? Keyword, at least one. Okay, so anytime I'm looking for at least one, I know my final answer will be 1 minus something. I'm looking for at least one club. The way we calculate at least ones is going to be 1 minus none. So 1 minus, how many fractions do I need here? Talking about 3 cards, so 3 fractions. 3 cards, none of them club would mean not club, not club, not club for all 3. So all 3 will be not club. Bottom of the cards is the same as all the other ones. How many different cards total? That's 52. And then we do have to reduce because we're not putting cards back. So 51, 50. For the top of the fractions, I'm looking for not clubs. So what are not clubs? Not clubs would be everything that's except for the first row. So second, third, fourth rows. Each row has 13. So 13 times 3, that's 39. Second fraction, I also want to be a not club. And then because we're talking about cards, we do have to reduce. So I already have a not club for the first fraction. I have to reduce by 1 to 38, and then reduce by 1 again to 37. So final answer is going to be 1 minus 39 over 52 times 38 over 51 times 37 over 50.